so big picture, right? What we've been doing in this class, and I kind of told you, right, is that every unit, right, we would kind of have like a function of the unit, right, kind of thing. So in unit 1, right, we learned about functions themselves. We talked about domain and range, increasing, decreasing, maxes and mins, zeros, all that kind of stuff, right? We talked about end behavior there too. But the function of that unit, right, was the absolute value function, right? And we shifted it left and right, up and down, stretched it vertically, right, okay? We flipped it maybe and stuff like that too. Then in unit 2, we moved on, right, and we talked, our big focus there was quadratics, not only graphing the parabola, right, and shifting it left, right, up and down, you know, stretching it vertically, and then all that jazz. But we also then factored, right? We solved quadratic equations, completing the square, factoring, right, using the zero product property, quadratic formula, all that stuff, right? That was that unit. And then for our current unit, right, we started out with cubics, right, and that was like kind of like our function of the unit, right, that we were using. So we, again, shifted cubics left, right, up, down, stretched them. All right, we solved cubic equations too, kind of. Anyway, but then we got into the more general polynomial equations, right? So for any degree, right, and so we were using, we graphed those too. We sketched the graphs there because we couldn't be quite as accurate, but at least we were able to find the end behavior, the zeros, and the middle behavior, and then plot those as a sketch, right? And then once we were graphing polynomials, we also went about solving polynomial equations. Right, and that involves factoring. So we use GCF, right? Most recently, we've also used, not long division. We used factor by grouping. We also factored, if there was quadratics, we could factor quadratics. Then we learned some special cases like the difference of squares yesterday, the sum of cubes, the difference of cubes yesterday. Okay, but we still realize that there's like polynomials that we can't quite factor yet, right? And the so what we're going to be doing today, and what we did yesterday, was we learned about long division yesterday, synthetic division today, and these are going to be tools that will allow us to widen how many kinds of functions that we can factor now, okay? Just because a function, there's no GCF, just because there's no factor by grouping that you can do, it's not quadratic or something, and it's not a difference or a sum of cubes or a difference of squares, just because none of those things doesn't mean that it still cannot factor, right? You still could factor. So like I said, today we're going to be looking at developing a way to factor some of these more difficult polynomials to factor, and then we'll finish it off tomorrow by looking at something called the rational roots theorem, which will give us like a list of possible zeros or things that will evenly divide our polynomials, okay? Even after tomorrow, though, we still will run across polynomials that we just won't be able to factor, okay? But that do factor, but we just won't be able to factor, okay? So, anyway. Synthetic division okay, just a quick note here, can only be used to divide polynomials by a divisor. Okay, so divisor, by the way, is the thing that you are dividing by, right? That's what divisor means. Okay, so synthetic division can only be used to divide polynomials by a divisor of the form x minus k. Okay, so here's where here's that limitation I was trying to describe to you. You cannot use synthetic division for any polynomial division problem you run across. You can only use it when you are dividing by something in the form like x minus k, or something that can be rewritten in the form x minus k. Okay. So in other words, right, that warm-up question that I showed you guys, that we had for the warm-up, right? Okay. What was our divisor in this particular problem? What's our divisor here? What are we dividing by? X squared plus 1, right? X squared plus 1 is what we were dividing by, okay? Is this in the correct form? Is this in the form x minus k here? No, okay? What about this? What about our divisor here makes it incorrect for that kind of form? It's got a square. Very good, Kobe, exactly right. Not the plus. Remember, a plus can be rewritten as a minus and negative, and so we can still have a k there. It's the square, okay? This is linear, right? This is quadratic, okay? So we cannot use synthetic division for this problem. We had to use long division. Had to. Okay? But for the special cases where we divide by x minus k, we'll be able to use this synthetic division. So let me show you how we're going to do that. So here's an example. And we'll do a few so you get the hang of it. Okay? Divide f of x, which is equal to x cubed plus 5x squared minus 7x plus 2. Divide that by x minus 2. Okay. So, is this division that we're supposed to do here, is the thing we're dividing by, okay, is it an appropriate divisor so that we can use synthetic division? Can we use synthetic division with this divisor? Yeah. Yes, okay. What is our k in this particular case? So remember here, the divisor is in the form x minus k, so just be 2, exactly right. Okay, so in this case, k is 2. Okay, k is 2. So here's how we set up synthetic division. We're going to draw like a little half box and put the 2, excuse me, inside that half box, our k. Okay. Next, we're going to write our lead coefficients, okay, from our polynomial. So what's our first coefficient? 1, and then 5, and then? Very good, yeah, -7. You do want to count those negatives, yep. And then 2 at the very end. Very good. Okay. If you are missing an intermediate term, so like in our warm-up again, right, in our warm-up here, right, we were missing the x term in this polynomial. What did we have to do for the x term when we wrote it in the long division? We had to put a 0x in, a placeholder, right? Same is true here. If you are going to do synthetic division, and you are missing a term in between, you need to put 0, okay? So, again, I'll label these here. These are the coefficients, okay, in order, and include placeholders. That's their zeros. Okay, they hold the place for those missing terms. Okay, so far so good? Again, I'm taking much longer than you guys will ever take on these in the future, but for right now, just for the setup and stuff like that, I want to make sure we get it all right. Okay, leave a line on your paper. Leave a line of space. We're going to fill numbers in here, so leave a line of space. And then put like a little bar here. Okay, it's like an equals bar. Okay, so now we're set up. We're ready to actually do the synthetic division. And here's all we're going to do. All right, we're going to start by taking our 1, and we're going to drop this 1 down below our bar. And we're going to reuse that. Okay, so that's how we started off. Then the 1, the number under the bar here, the 1, we're going to take and multiply with the 2. Okay, so drop the 1, and it's 1 times 2. What's 1 times 2? 2. And we're going to put that 2 right here. Okay. The 5 and the 2, we're going to add. What's 5 plus 2? 7. Okay, and we've now completed one full step of a synthetic division problem. Okay. The 7 is just like the 1, right? It's like in the same kind of position you can think of, right? So what should we do with the 7? Multiply by the 2. Exactly right. So we did 1 times 2 and get the 2 here. We're going to do 7 times 2. 7 times 2. I should put the right add in here. There we go. Well, we'll do the 7 times 2, 14, and we're going to put that right here. Okay, and we add 14 and negative 7, 7 again. And then what should we do with this 7? Times 2 again. You're right. 7 times the 2, 14. Okay, and then we're going to add again. 2 plus 14, 16. Okay, now, how do we interpret this result? All right, how do we interpret this result? Well, let me show you. Okay, let me show you. You'll be able to figure out once I do it here. So, again, synthetic division, unfamiliar to us. Let's do something more familiar. You guys don't have to write this down along with me if you don't want to. Just follow along, please, at least. I'm going to do this by long division so you can see what this result means. And you might already have an idea in your head about what this result means. Okay? So I'm going to do long division here. So what times x gives me x cubed? What times x gives me x cubed? X. I have an x. What times x will give me x cubed? X to the x squared. X squared. X2, x squared. X squared times that, x to the third. X squared times that, minus 2, x squared. Subtract the quantity. Okay, I don't like subtracting, so I'm going to make it add the opposite. X cubes cancel. 5 and 2 make 7x squared. Bring down the minus 7x. What times x gives me 7x squared? 7x. So 7x times x, 7x squared. 7x times minus 2, minus 14x. Subtract. Okay, but again, I don't like subtracting, so add the opposites. 7x squared cancels. I get 7x. Bring down the plus 2. Okay. What times x gives me 7x? 7. 7 times x is 7x. 7 times minus 2 is minus 14. Again, subtract the quantity, but I don't like subtraction, so I'm changing it to add the opposites. The 7x is canceled. 2 and 14 make 16. My remainder then, right, because I can't, making this worse and worse. There we go. My remainder is 16. So plus 16 over x minus 2. Okay? So, what are these numbers that we got from our synthetic division? What are these numbers that we got from our synthetic division? How do they relate? Yes. Okay, it's in the order of the what? Sorry? Let's see here. Oh, I think the answer you're saying up top. Ah, okay. Yeah, these 1 is the coefficient here of x squared, right? 7 is the coefficient of x. 7 is the constant term. And then 16, what's that? It's our remainder, okay? And in fact, that is how it will always be. This number will always be the remainder. Okay? And then these are going to be coefficients of our answer. Okay, but if we just know the coefficients, how are we supposed to know like whether it's x to the 4th or x to the 3rd or x squared or something like that? Well, what degree did we start with? We started with degree 3, okay? We divided a degree 1, so we're going to... Exactly. We knocked the degree down by 1. So we end up with 1x squared plus 7x plus 7, and then plus the 16 over the x plus x minus 2. Okay? So there, okay, are where those numbers go and how we get our answer there. Okay? All right, it's pretty slick. Pretty slick. Let's try another one. Or any questions before I move on? Okay. All right, let's try another one there. Divide f of x equal to x squared plus x minus 17 by x minus 4. Question? You getting this okay? Yeah. And go ahead. All right. Can we use synthetic division here? Yeah. Yes, because we're dividing by x minus 4, okay, which is in the form that we need, right? X minus k there, so this is x minus 4. All right, very good. Let's go to Blake. So Blake, then, what is our k in this case? So careful, not negative 4. 4, because again, x minus k is the form, so we just want to take just the opposite of that number there. So not minus 4, but positive 4. We'll put that in our little box. Okay, very good. Thank you, Blake. Let's go to Allie. Allie, then, what goes across the top here?
1 negative 17.
Yeah. That's it. Yeah, that's all there is. For this one, there's only 3 terms, so you need 3 numbers. Yeah. Make this one a quadratic. Okay. So then again, put a bar underneath. Leave a line of space. Leave a line of space. We're going to put numbers in here, right? Okay. Very good. And then Logan, how do I start this thing off? What do I do first?
Then bring down the 1.
Bring down that first 1. You can draw the arrow if you want to, or you can just put the 1 there. It's your choice. Okay, and then Logan, with that 1, what are we going to do now?
Multiply by
So times the 4, which gives us 4, and then that goes
That's the 1.
right here, underneath, yeah, right here, right there, is where we want it. Not really an easy way to describe where it goes, I guess, but that's where it is. All right, very good. And then from here, Logan, with the 1 and the 4, what do we do?
You
Add them, that's right. And then just repeat. 5 times 4, 20, negative 17 plus 20, 3. Okay. Does x minus 4 evenly divide this polynomial? No, because the remainder is 3 and not, right, we want a 0 there. Okay, so again, and we need to interpret these results correctly here too. So let's go to Patrick. Patrick, with these results, what are my answers going to be then? What's my answer going to be to the division?
1x.
X or 1x.
Plus 5.
Minus
-3.
We'll say plus 3 because it's a positive 3, and then over the x minus 4. Just like that. Okay. There's our answer. Much better than long division, right? Much better. Of course, it's limited though, right? But it's much better. Much better. We're going to be using synthetic division more, but you will see some long division problems. Come on, Teresa. Because why would I teach it to you if I didn't get to torture with you on a test or something like that, right? So, all right, Josh, question? The remainder? It's just the leftover number there. And then because that still is remaining, right, that we were unable to continue to divide that, and so it still has to be divided by what we were dividing by originally, the x minus 4.
So the last number is just always going to be
Over whatever you were dividing by. Yep. Just like when we were doing the long division stuff yesterday, right? Here, for example, we had that 16 left over, right? That still needed to be divided by the x minus 2, but we just couldn't anymore, so we just have to add on plus 16 over x minus 2. We just couldn't continue the division, so we had to stop. We still want to show that that is there to be divided. All right. Try another one here. One more together, and then I'll have you guys try one on your own, okay? Divide f of x equal to x to the third minus 64 by x minus 4. Actually, I'm going to change this one up. Sorry. We'll make it x cubed plus 64 divided by x plus 4. Just changing the signs there. Okay. Now, I hope little alarm bells are going off in your head, especially after what we learned yesterday, right? This x cubed plus 64, right? This is factorable, right? Because these are both perfect cubes. So this is a sum of cubes here. So we could factor this, right? But we're trying to divide. Factoring and dividing is not always the same thing. But you'll see in this case it ends up being that way. Anyway, so this is a sum of cubes right there. We could factor that thing too. All right. What goes in the box here? What? Our k is -4. Yep, -4 is our k. Very good. All right, and let's go to Madison. Madison, what numbers go across the top here? Sorry? Do we need placeholders, everybody? Yes, we do. 1, 0, 0. Very good, okay. Very good. Good catch there. Yes, we need placeholders. Very good, Madison. Okay? All right. Do the same thing we did before here. So we'll drop that 1 down. 1 times negative 4 is negative 4. 0 plus negative 4, negative 4. Okay. Multiply again, negative 4 times negative 4, positive 16. Add, you get 16. 16 times negative 4, negative 64. And then these add up to make 0. Hey! Is x plus 4 a factor of x cubed plus 64?
Yeah.
Yes. We have a remainder of 0. Okay. We knew that already, though, from our sum of cubes formula, right? But in other words, I can take this. Oops, let me do this down here. So this is, so what's the degree of our answer going to be? 2, right? So it's going to be x squared or 1x squared minus 4x plus 16. And so then I can take my original function here and say, oh, that's going to be equal to then x plus 4 times x squared minus 4x plus 16, right? If I took this and divided out the x plus 4, I got this in my answer. So if I multiply these two parts back together, they will give me the original function there. Okay, in reverse. All right. Questions on any of that? All right, I got one for you to try here. Question? Sure. You get this okay, Sierra?
Yeah.
All right. Oops, that's not what I wanted to write. Sorry. All right, so here we go. Here's one for y'all to try. Okay, I want you to factor, nope. I want you to divide f of x equal to 3x to the third minus 4x squared minus 28x minus 16 by x plus 2. Okay. And then 2, I want you to factor the result. Okay. So, divide, factor the result, factor your answer. Okay, and you can use whatever method you want. So, Teresa, I think, is going to use long division because she loves it so much, but y'all can use synthetic division if you want to, okay? Your choice. How much do you like to torture yourself? drop down the 3 first. Just leave it as 3. And then you do 3 times negative 2, which is negative 6, and then you're going to add. Trying to factor the result. Okay, once you guys do the synthetic division or long division there first, then please take your answer and try to factor. Oh, I see what the issue is. You can still divide. So yeah, this is not the remainder yet. So we stop the remainder yet. Because you can still what times x will give you negative 8. So negative 8, yeah. So we're going to multiply by negative 8. Yes, Mark. Okay, your setup looks good. Oh, I see. So that should be negative 2. So because it's the format is x minus a plus 2. So basically, you always want to just whatever you're trying to divide by, you want to use the opposite. Okay, that's the idea. So 3 times negative 2 is negative 6. And then negative 4, negative 6 gives negative 10. 20, negative 8. Negative 8 times negative 2. Okay, here? Oh, okay. So then you have to should know everything. Yep. That's okay. It does kind of stink. Because we make that mistake early on, and everything is wrong after. So if you were cubed, your answer is going to be 1 degree less squared. Because you imagine you're taking a degree 3, taking some degree 3, you divide out a degree 1, so that you lower the degree by 1, right? Kobe? Yes, much better. It does divide even. It should divide even. Yep. And then try and factor that result. I'm going to show you here right now, so y'all can see. Okay. So there is the synthetic division with your result, okay? Right there, 3x squared minus 10x minus 8. All right. And then I asked you to then factor your result. So there's the answer for number 1, okay? And here's the result factored, which does factor, right? And that's just a quadratic. So you would factor using the a times c method, right? 3 times negative 8 gives us negative 24. What two numbers multiply to make negative 24 but add to make negative 10? Negative 12 and positive 2, factor by grouping, and then, go from there. Okay. What does this mean? What does this mean? Well, we've taken a cubic, whoops. Okay, we took this cubic here, and we were able to factor out an x plus 2, and then the result factored to be this x minus 4 times 3x plus 2. All right, and so we were able to take this cubic and factor it. Okay, we were able to take that cubic and factor it there. All right. This cubic does not otherwise factor with any other strategy we know. Sorry, Madison, if you're ready, if you want to go, Madison. This cube does not factor any other way that we know. Okay, if you look here, right? Factor by grouping. You can factor something out of here, you can factor something out of here, but it's not going to be the same thing, okay? This will not factor by grouping if you try. There's no GCF, okay, it's not quadratic, so you can't factor it like it's a quadratic. All right, so this doesn't factor by any other strategy that we have, but we were able to actually get it to factor. What's the problem with the strategy, though, that we used here? We need to know what you're dividing by. You have to be a very good guesser, right? If someone has to tell you, hey, by the way, this is a factor, use this one, okay? Right? In GCF, in factor by grouping, and all the others, in the other forms that we know, you don't need to know ahead of time what the factors are. They just kind of appear. You see them happen, right? For the synthetic division and for long division, you need to know what the factors are in order to actually do the work, right? Or just have to guess them. So that's what we're going to be doing tomorrow is guessing. Okay, but we're going to guess from a limited list. Okay? So that's what I've got for you there. Okay? One other thing I want to show you here real quick is, and this is just like a little side thing too, okay? Let's say we've got, given f of x equals x to the third minus 6x squared plus 5x plus 12. Okay? So let's say that's what we're given, and we want to find, find f of 2. Let's scratch out there. Find f of 2. Right? Let's say we wanted to evaluate the function at 2. What would we normally do here to evaluate the function at 2? What would we normally do? Plug 2 in where? Yeah, for all the x's, right? And you just simplify it. You can actually use synthetic division to do this. Okay? So in my box, I'm going to put in the 2. Okay? So we're going to put 2 in the little box here. I'll put my coefficients in. 1, negative 6, 5, and 12. Okay? Drop the 1 down. 1 times 2 is 2. Negative 6 and 2 is negative 4. You get negative 8, so negative 3. And negative 3 times 2 is negative 6. So we get 6 here. Your remainder is what your answer will be when you plug 2 in. I'll show you. Okay, so let's do what Teresa said there. Let's plug 2 in for x. Okay, so 2 to the third. Let me do it with a pretty type. 2 to the third. I'll use parentheses. Okay, 2 to the third minus 6 times 2 squared plus 5 times 2 plus 12. 6. Okay? So you can use synthetic division to maybe more quickly evaluate a polynomial too if you wanted to. Okay? And in this case, you don't do the opposite. You plug in the box exactly, you plug inside the box exactly what you're evaluating at. Okay? And then you can evaluate a polynomial much more quickly using that synthetic division algorithm. Okay? So that's all I got for you today. I'm going to give you your homework. You get started on that. Okay, you have a good amount of time here to do it. In your book on page 237 to 239, I think, and this is, I think, 6 dash, I'm not sure what second, I'll take a look at that. It's going to be numbers 139, 10, 13, 15, 20. Okay, 139, 10, 13, 15, 20. Okay, there are books in the back of the room too if you don't have your book on you, but we have power now, so you can also look up the book online as well.